Okay, let's try a slightly harder calorie problem. And you go, oh no, not that hard one. Okay, let's try this. 50 grams of ice is put into 400 grams of boiling water. Assuming this is an adiabatic reaction, adiabatic system, so no heat is lost to the outside, no heat comes in. What is the final temperature? What is the final temperature? Okay, well, we've got two things here. We've got the change in energy of melting the ice. And well, we're going to need a little bit of data. What do we know? Well, we know C for water is going to equal the specific heat of water is 4.186 joules per gram per K. We know to melt the water, the latent heat of fusion of water is equal to 334 joules per gram. Anything else we know? Temperature of ice equals 0 degrees C. We're going to, and temperature boiling equals 100 degrees C. So what we actually have here, heat of fusion is going to equal the mass times the latent heat, which is equal to 50 grams times 334 joules per gram equals, I'm getting too old for this, 334 times 50, 16,700 joules. So this is part one. Let's just find out how much energy it takes to melt the ice. So what does that reduce? How much does that reduce the temperature of the boiling water? So the change in heat of the ice, so the change in energy of the ice is going to equal the change in energy of the boiling water. Change in Q of the heat of the boiling water. So what's that going to equal? That's equal to mass of the water, specific heat of the water, by the change in temperature, temperature final, minus temperature initial. Now I know the temperature initial for the boiling water is going to be 100 degrees C. So we worked out that this is 16,700 joules. Okay, when we're sticking numbers in like this, just ignore that bit. When we're sticking numbers in like this bit, we don't stick the units in, otherwise we end up with all these tabs and things that gets confused. Equals the mass of the water, 400 grams, times the specific heat of the water, 4.186, times T final, don't know it, minus 100 degrees C. That's the point. So we now simplify this out. 16,700 divided by 400 divided by 4.186 equals TF minus 100. All I did was I divided both sides by that. So what's that? 16,000 divided by 400 equals divided by 4.186 equals. So the change in temperature, okay, so 9.974 equals TF minus 100. What did I do here? I screwed up. Why did I screw up? How did I screw up? What I did not do, remember, when I did this, this is equal to the negative, because the heat goes from here into here, or it goes from here to here. So these are going to have opposite signs. So this is going to be negative. This is going to be negative 16,000. Negative. So this is going to be negative 7 point. So TF is going to equal, just rearranging this, 100 minus 9.974. So the temperature final here is going to be 100 minus answer equals 90.03 degrees C. So that's at the end of stage 1. At the end of stage 1, how much did the temperature cool down by? So this is 1. So stage 2, well, what are we going to do now? We now know that the temperature cold for the second part is still going to be 0 degrees Celsius. Remember, when the ice melted, it did not change temperature, it changed phase. So all of this energy up here was to change it from solid into liquid. It doesn't change the temperature. So the cold water, this 50 grams, is still 0 degrees Celsius. The mass of the cold water equals 50 grams. The temperature of the hot water, that's what we just worked out here, is 90.03 degrees C. And the mass of the hot water is equal to, we worked it out, where was it? 400 grams. And CF water hasn't changed. It's still equal to 4.186. Okay, so now how do we work this out? The final bit out, and we worked that out the same way that we did before with sticking the iron into the water. So what we have here, we make up, so the change in heat of the hot equals the negative of the change in heat of the cold. So the change in heat of the hot is the mass hot water, specific heat of the water, because remember, it's all water now. It's mass hot water, specific heat of water, temperature final, because that's what we're trying to find for part 2, minus, well, it starts off as hot water, top temperature hot, initial, equals negative mass cold, specific heat of water, temperature final, minus temperature initial cold. Okay, you'll notice there's a CW on both sides. Get rid of those. Stick in what we know. So mass hot is equal to 400 times temperature T final minus T initial for hot, which is 90.03 equals negative 50 temperature final minus T initial C, which is equal to minus 0. So we can get rid of this. So this side just simplifies down to negative 50 TF. So this is going to equal 400 TF. This is just expanding the brackets, minus 400 times 90.303, equals negative 50 TF. So that's 400 TF minus times 400 equals 36,105 equals minus 50 TF. Now what we do is we just rearrange everything that's TF comes across to this side, so we add 50 to both sides, 400 TF plus 50 TF equals, and then I have to get rid of that, so I add that to both sides, equals 36,105. We simplify this out, this is equal to 450 TF equals 36,105. We divide both sides by 450 and that will give us the final temperature TF by 450 equals 80.02 degrees C. So basically, with my 400 grams of water, I add 50 grams of ice. The final temperature, once the ice is melted and then the ice is warmed up to the rest of the temperature, it's going to be, equilibrium temperature is going to be 80 degrees Celsius. And that's assuming no heat loss going out, no heat gained by coming in.